Okay. Sorry for it. I will just share screen right now. So in the meantime, as you know, we have a quiz today, and the password of quiz is Congress. I will send it to email. So and it will take the two programs in one piece. So please be prepared. And okay, now I turned on my Zoom in the classroom. Okay, then share the screen. Oh. Oh, yeah, today we need to start the new section. Okay, so the chapter quiz will be on the chapter 14. So, and if my memory is correct, then it will be about the Hamilton method and one divisor method. So I think you need to study about the divisor method and Hamilton method before taking quiz to get the pre-credit. Yeah, one Hamilton method and divisor method. Yeah. Yes, for the quiz today. Yes. Pardon? 30 minutes. Good. Perfect. Question? Okay, then we will start the chapter 9. So as you already know, yeah, that's the last quiz. And after last quiz, you can get your final answer. Okay, question? There are three divisor methods: Jefferson, Webster, and Hill Huntington. So it will be one of that method. So it will be just comparing the result when you use the Hamilton method and one of the divisor method. Okay. Okay, so I don't know why it takes a lot of time. Okay, great. So today we will do about the chapter 9. So chapter 9 is about the introduction to social choice. So yeah, for example, there are so many social choice, but one of the social choice for you is the election for American president, right? So to elect someone as your US POTUS, you need to choose someone and voted for them, right? So in that kind of situation, what the society need to choose someone or some kind of policy, then they will ask each one of their opinions and they need to correct it and need to choose social preference or kind of social decision for which policy or which person will be elected or choose for the society's policy or society's president, right? So that's called the social choice. And there are two very traditional methods in the social choice. And one is called single vote ballot. So single vote ballot allows voter to choose one person for each position, right? So for example, if you think about the current election for United States of President, then you cannot choose both Trump and Obama, or both Trump and Biden in simultaneously, right? You need to choose only one person, or you not choose any person, right? But it is not allowable for us to choose the same person, choose the different person at the simultaneously, right? So that's called single vote ballot. And the example is the presidential election. However, there is something called a preference list. So in the case of preference list ballot, then you can just choose not only one person, you can choose several person, but you need to decide who is the first rank and who is the second rank and who is the third rank and so on. So for example, if we allow preference list on the presidential election, then maybe you can just set your order of preference as Biden, Trump, and George Jorgensen or something like that. Or you can choose Trump, Biden, George Jorgensen or something like that. Or maybe you can put George Jorgensen on the first rank and Biden or Trump will be on the second rank or so on. So in case of preference list, you need to just show what is your rank for each alternative or each candidate of the election. And we will just aggregate all those rank and choose the society's preferential list. So that's called preference list ballot, right? So usually it will be adopted in some states in the European states, like Sweden or Denmark, but I don't know the case of the American case. So yeah, I'm not sure that whether there is some example or not, but yeah, it will be very common in some Northern European states. So in that state, to analyze those things, we will see that if, for example, if candidates, sure, there are 3 candidates, then we can write down ABC as the first one is just first rank choice. And this one is second rank choice. And the last one is third choice, which means that you prefer candidate A than candidate to candidate B, and you prefer candidate B to candidate C, right? Then for example, if you choose CAB, it means that you prefer C to A and prefer A to B, right? Then someone who has his preferential list on CAB, is it does he prefer C to B or does he prefer B to C? C to B, right? Because he prefers C to A and he prefers A to B. So usually we assume that he also prefers C to B because B is inferior to A, which is inferior to C, right? So from this, you can conclude that, yeah, you prefer C to B, right? So that's the preference list. So when we write down preference list on those candidates, then we just write down some, some concatenation of letters, so that each letter in the leftmost side denotes the first rank choice, and second one is second rank choice, and so on, right? So using that preference list, we will see some kind of rules on social choice method, right? Okay, do you have any question before going further? Okay, question in the Zoom. Okay, then let's deal with first method for social choice. So the first method is called the majority rules. So here, the majority rule means that each voter votes for one candidate, and the candidate with the majority of the vote wins. So majority means more than half, right? So for example, if there is just 3 candidates, A, B, C, and if A got 51% of the votes, and B got 29% of the votes, and C got 20% of the votes, then who wins? A wins, right? Because A got the more than half of the votes, right? However, if they're again the same candidate, but if A got 34%, B got 33%, and C got 33%, then who wins in this case? No one. Great. So in this case, nobody wins. So in this kind of case, we will adopt some other method, like the just adopting the first two and make both again or something like that. So it will be also learned in the future chapters, but yeah, in this case, majority rule does not care, right? So from this, you can see that in the case of majority rule, the only cases we know happen is when someone got the majority of the votes, which means someone got the at least half of the votes, right? Otherwise, majority rule cannot determine the winner, right? So that's the majority rule. Okay, do you have any question? Okay, then, and then next rule is about the Condorcet rule. So here, Condorcet's method, actually he is from French, so but I don't know the pronunciation of the French, so I just say Condorcet. So and each voter ranks the candidates in preference with voting, right? And if each candidate is compared to every other candidate, and if one candidate wins all of his or her own one contest, so which means that if you have 3 candidates, then you can just count who thinks that A is great, who prefers A to B. So you can just make the A to B and B to C and A to C, and just choose winner for each cases, right? So if there is some candidate who wins every other candidate in one-on-one fight, then we can see that that one is the winner, right? But otherwise, for example, if A wins B, but B wins C, but C wins A, so in this kind of case, then nobody is a winner in this case, right? So let's see some example because it's a little bit abstract. So if you see the example, then you can see what I mean. So see example 2.3. So that assume that following list reflects the voting preferences of all voters So here, person X, Y, Z means that it is just X is X wins Y, but Y wins Z. Or you can see that the voter who votes about this preference list X, Y, Z, they actually prefer X to Y, and also they prefer Y to Z. So definitely they prefer X to Z, right? And there are 5 such voters in here. And there are 2 other voters that vote on the preference list YXG, which means that they prefer Y to X, and they prefer X to G, so they prefer Y to G. And there are 1 voter who votes on YGX, and there are 4 other voters who vote on GYX, right? So in that case, to get the majority winner, you need to think about the first letter in each cases, right? Then the voters who prefer X most is 5, right? Because it is in here or here, the voters prefers list XYG or XGY definitely prefer X the most, right? But there are only 5 voters in here, so that's why it has 5. And voters who prefer Y the most is from here and here. And if you add those 2 numbers, then it is just 3, right? And lastly, voters who prefer G is from the last 2, and this is 4. So from this, X has 5 votes, Y has 3 votes, G has 4 votes. And in this case, you can see that the number of all voters are 5 plus 2 plus 1 plus 4, which is 12, right? So to win your majority rule over majority rule, one candidate should get half, which is in this case 6, right? Because half of the 12 is 6 of the votes. However, you can see that there are no candidates who get the half of the vote, right? Even if X gets the most vote, but what X gets is 5 votes, but 5 is definitely less than the 6, which is half of the measure, right? Or half of the whole voters, right? So in this case, from this, you can see that no one wins in the majority rule. Pardon? Yes, if somebody get the 7 votes, then definitely he wins or she wins, right? But in this case, nobody gets more than 5, 6 votes, so there is no one, right? Yeah, at least 50%, yes. Mm. No, in case of 50%, he wins. So it is including 50%. What I mean major means that it is equal or more than half. Yeah, equal or more than half. So in case of only one case, the majority rule gives you no winner, even if one can get half, is there are only 2 candidates. So for example, if there is candidates in here, then A got 50% and B got 50%. So in that case, there is no winner. But if it is in kind of this kind of case, so A got 50%, B got 49%, C got 1%, then A is winner. Does it make sense? Okay. So what Abud and Haley pardon? Mary, sorry about that. What Aviud and Mary asked us is that if there is a 7 votes, there is a candidate who got the 7 votes, then he definitely wins. And what Abiu says that if someone got the half of the votes, then he wins. Only if in this kind of case. So, but if there is a some other cases, like A got the half of vote and B also got the half of vote, then they do not. Yeah, no winner. Okay, great. No winners. Okay. Do you have any other question? Great. Then let's read about the Condor's winner. So here, it is the same preference list and same voters. But if you think about the contest between X and Y, then first of all, when you can see that in the preference list X, Y, Z, there are 5 voters. So definitely at least 5 voters thinks that X wins Y, right? So first of all, there is 5 voters. And in case of X, G, Y, there is 0 voters, but if there is some voters who prefer this X, G, Y, then it means that also there are some voters who think that X wins Y, but in this case, it is 0. And in the case of Y, X, G, so this is for X is greater than Y. And in case of Y, X, G, it means that 2 voters think that Y wins X, right? Well, they prefer Y to X. So there should be 2 voters who think that Y is greater than X. And again, in YGX, at least 1 voter thinks that Y is preferable than X. So you need to add 1 in here. And for case GYX, it also means that they prefer Y to X, right? So it means that Y wins X, so you need to add 4 in here. So, and in case of GXY, there is no butter, so these are all the cases. So there is only 5 votes who thinks that X is better than Y, but there is 7 votes who thinks that Y is better than X, right? So it means that the winner is Y, right? Does it make sense? Okay, let's do the similar thing for X to G. And for the first preference XYG, definitely the voters in XYG thinks that X is better than G, right? So because G is the last rank, X is the first rank, right? So in this case, at least 5 voters thinks that X is better than G. And also case YXG, because XGY has no voters, so we don't need to care about that. But in case of YXG, still voters who have preference list on YXG thinks that X is better than G, right? So you need to add these 2 voters in case of X is greater than G. And in case of YGX, in this case, voters thinks that, yeah, the voter in this YGX thinks that G is better than X. So you need to count this 1 voter on the second line, which is who thinks that G is better than X. And in case of GYX, again, voters in the preference list of GYX thinks that G is better than X, right? Because G is better than Y and Y is better than X. So in this case, again, you need to add 4 people in here. So if you add those numbers, then voter who thinks that X is better than G is 7 votes. But voters who thinks that G is better than X has only 5 votes. So here is winner is X, right? Good. And lastly, do the same thing on Y to G. So here, first line is for someone who thinks that Y is greater than G. And the second cell is for G is greater than Y, or G is better than Y. And for the preference is X, Y, G. Definitely voters in X, Y, G thinks that Y is better than G. So you need to add 5 on the first cell who thinks that Y is better than G. And voters in YXG also thinks that Y is better than any of the candidates. So you need to add those two people in the first cell again. And voters in YGX also thinks that Y is better than any of the candidates. So you need to add those number 1 in the also first cell. And lastly, voters in GYX think that G is better than Y. So you need to count those voters 4 in the second cell. And if you add all the number, then first cell gives you 8, but second cell is 4. So definitely there are more persons who think that Y is better than G. So the winner is Y, right? Is it good? Then you can see that in this contest, Y wins X, and also Y wins G, right? And there are only 3 candidates, and Y wins any of the other candidates, right? So in this case, we say that the controversial winner is Y. Since Y beats every other candidate in 1-to-1. Better, right? So that's the concept of controversial winner. Pardon? No, they have to win all of them. So that's why I said that Y beats every other candidate. Yes. So if there are some other candidates who beats Y, then there are no controversial winner, right? So the controversial winner must beat every other candidate in 1-to-1. Okay. That's a good question. Okay, do you have any other question? Good. Then let's see some other examples. So here, example 2.4, assume that the following list reflects the voting preference of all voters. And we want to find the controversial winner in this case. Then again, there are 4 voters for each preference list. And in case of the first preference list, definitely voters in the ABC thinks that A beats B. So we need to fall in here who thinks that A is better than B. And for the other one, B is better than A. And we just count 4 for A, someone who thinks that A is better than B. And in the second preference list, B is better than A. So in this case, we add 4 voters in the second contest. And in the third one, CAB, it definitely those people in the CAB thinks that A is better than B. So you need to add 4 in A, B, as B. So if you add, then there are 8 people who thinks that A is better than B, but 4 people who thinks that B is better than A. So winner is A, right? Okay. Then we can do the same thing on ABSC. So for the preference list ABC, 4 persons definitely thinks that A is better than C because A is better than B and B is better than C. So we need to count 4 for this case when A is better than C. And for their preference list BCA, people in here thinks that C is better than A, so you need to count those 4 people in the second one. And in the preference list CAB, again, C is in the leftmost side, so definitely people in this preference list thinks that C is the best for among all other candidates, right? So you need to count those 4 people in here in the second cell. So in this case, A people thinks that C is better than A, so winner is C. And you can do the same thing for B, B, and C. So here, for first preference list, B is better than C. So those 4 people should be counted on the first cell, which thinks about the B is better than C. And those who in the middle preference list, definitely B is better than C. So those 4 people are also counted in the first cell. And for the people in the rightmost side, CAB means that C is better than B. So those 4 persons should be counted on the second cell. So again, there are 8 persons who thinks that B is better than C, which exceeds the 4 person who thinks that C is better than B. So here winner is B, right? Does it make sense? Good. Then you can see that, so from A to B, A wins B, right? But from A to C, C wins A. But from B to C, B wins C, right? So that's kind of circular thing, right? So in that case, we cannot choose the winner in the Condorcet method, right? So that's the case when the Condorcet method has no winner, and it is called Condorcet paradox, right? So we just aggregate all possible ranks from the people, but it gives kind of circular rank. Then in that case, we cannot choose the winner, right? It's kind of rock, scissors, paper, right? If someone has rock, but there is scissors who prefer scissors, but scissors, someone who prefers scissors also prefer definitely, paper, but sorry, yeah, it should be changed. So someone who prefers scissors definitely more prefer than rocks, but someone who prefer rocks definitely more prefer to see paper, and for someone who prefer paper, definitely who prefer also scissors because scissors wins the paper. So it is kind of a circular thing, right? So in that case, we say that it is Condorcet paradox, and we cannot decide the winner. Right? Okay. Do you have any question? So from this, yeah, those majority rule and Condorcet rule seems reasonable, but sometimes it doesn't give us some winners, right? So therefore, there are some other voting systems will be suggested. And one of the voting system is plurality voting. Actually, that is most common voting system in here. So in the plurality voting, each voter votes for one candidate. And the candidate with the most votes wins, right? So for example, think about the situation where there are 3 candidates and A got 34%, B got 33%, C got 33%. In case of majority rule, there are no winners, right? But in case of plurality rule, yes, so in the majority rule, no winner. But in case of plurality rule, A wins, right? Because the votes from votes which A got is the most votes in this election, right? So that's the difference between majority rule and plurality rules. So sometimes it will be used to criticize the presidential election of the United States because in case of 2000 presidential election or in the recent 2016 presidential election, actually some, George, in the 2000 presidential election, George Bush, who is from the, uh, wants the plurality votes, actually polling data indicates that Al Gore would have won using Condorcet method. Or in case of the 2016, actually Biden got more votes, but actually the winner is Trump, right? So these are some cases that plurality voting does not work in some sense. So let's deal with this plurality voting for some examples. So assume that the following list reflects the voting preferences of all voters. So here it is actually the same preference list we use in the example 2.3. And in this case, again, to get the plurality winner, we need to count who prefers X the most. And this is just 5 plus 0 because here these two preference lists, XYZ and XGY, the voters in this preference list definitely thinks that X is the most better candidate, right? So this is just 5. And likewise, the voters who are in the YXG or YGX thinks that Y is the best candidate. So this one should be 3. And voters in the GYX or GXY also thinks that G is the best candidate in here. So it should be 4. And in this case, again, there are no majority winners, but there is definitely plurality winner who is X, right? Because 5 is the greatest among all other votes, right? So plurality winner is X. Right? Okay, do you have any question? Okay, then let's go with this manipulable voting system. So a voting system is called manipulable, which means that if there are elections in which definitely it is voters' advantage to submit a ballot that misrepresent his or her true preferences. So for example, in this election in 2020s, there are definitely some people who don't want Biden, but also there are some people who didn't like the Trump. So even if he is in the Republicans, but he votes for the Biden. For example, I've heard that in the, yes, some people from the Bush's administration actually give some money to Biden's election because they do not like the Trump. Likewise, there are some someone who are in the okay, in the 20s, actually there are someone who don't like Al Gore and also give some money to the on the George Bush's administration. So those kind of things actually happens in the plurality system. So in that case, even if they don't like both of the candidates, but they just give some votes for someone who didn't like because they do not want to the other one be the winner. So in that case, we says that this voting system is manipulable and plurality voting system is manipulable. So because, yeah, that's one of the example, that manipulable example. And it is known that one of the strengths of Condorcet method is that it is not manipulable, which means that if you do try to manipulate, so what I mean, try to misinterpret your own ranks on the Condorcet system, then you cannot get what you want, right? So it means that in the Condorcet method, it is your best strategy to just be honest. Otherwise, yeah, you cannot get what you want. So that's why sometimes conversion method is much more better than priority method, even if it is a little bit more complicated than priority method. Okay. Do you have any question? Okay, good. So in the exam, I usually just give some situations about the preference list and butters. And what you need to do is just try to using some given method like priority method or majority method or conversion method to determine who is the winner or who is not a winner, or if there is no winner, then what happens, like that. So you can just determine those things, then you are fine. So another method, which is also kind of the complement of the conversion method, is called border count and rank method. So here, rank method for voting means that just not only give each voter to 1 point, but just allows them to give 2 points for some voters and 0 point for other voters or something like that, right? So it's like the basketball, right? So in the basketball, if you just shoot on the in the circle of the 3-point line, then you definitely got the 2 points. But if you just got the shoot on the outside of the 3rd-point line, then you got 3 points, right? Like the basketball, you can also give some preferable candidates to 3 or 4 points or something like that, and some other candidates gives 1 or 2 points or something like that. So you can actually rank each candidate by using your own points, right? So that's the rank method of voting. And especially there are some kind of special rank method. So if you have n candidates, so for example, if you have 3 candidates, then you definitely you have some preference list, right? So you can make some preference list. So for example, you definitely prefer B to A, but you also prefer A to C. Then in this case, we can just assume that B got the n-1 point, which is 2 points. Sorry. And A got the 1 point, and C got the 0 point. So in case of n candidates, the pretty first rank candidate got the n-1 point, and second rank candidate gets the n-2 points, and third rank candidate gets the n-3 points, and so on, so that the last place last place candidate receives 0 points, and this is called the border counting. Right? So in the just original rank method, you can freely choose which points you will give. So for example, in the usual rank method, you can just give B to 3 points or and A to give zeros on A and B, C, right? Or you can just give 1, 1, 1 for each of the preference, right? But in case of the special case, which is called border counting, then you must give the n-1 points for the first rank, n-2 points for the second rank, and so on, right? So that is kind of special cases of the rank method. Okay. Do you have any question? Okay, then let's deal with some example. Okay, so here, assume that the following list reflects the voting preference of all voters. And again, this is the same list we deal with in the 2.3. And first of all, we want to find the priority winner. And we already find priority winner, which is X. But here, what we want to find the border count winner. Sorry, that's my typo. So border count winner. And in the border count, first place definitely gets 2 points because 3 minus 1 is 2. And second place definitely gets 1 point because 3 minus 2 is just 1. And third place gets 0 point. And there are 5 people who thinks that X is the first place. So we need to multiply 2 points in here. And there are 2 and 0 people. So 2 people will just think that X is the second place, right? So you need to multiply 1 here. And there are, again, 5 voters who thinks that X is the worst choice. Right? So in that case, you need to multiply 5 times 0. So per first one, you got 10 points. For the second place, you got 2 points. For the last place, you got 0 points. So X has total 12 points, right? Does it make sense? Or question? So what I had is I just investigate how many voters thinks that X is the best choice. And that happened in these two preference lists, right? In these two preference lists, X is the first choice. So I just multiply, and there are only 5 voters who chose those preference with greens. So I just multiply 2 points for number of those voters. And I can do the just same thing on voters who thinks that X is the second choice. And there are 2 voters thinks that X is the second choice, which are in the red. So I just multiply 1 point for each second choice voters, second voters voting. And for the last, those blue circles, voters in blue circles thinks that X is the worst choice. So in that case, we just didn't give any point, right? And by adding all those points, you can get 12 as the point for what point X on, right? Good. Great. Okay, let's do the same thing here. Here, first of all, we need to think about the case Y. So just delete all of them. Then, first of all, who thinks that Y is the first choice is in these red circles, right? And there are 3 persons thinks that Y is the best choice. So Y got 6 points from the first place. And for the second, there are 2 preference lists, XYG and GYX. They think that Y is in the second place, right? So, and there are 9 voters who thinks that Y is in the second place. So you need to multiply 9 with 1 point. So Y got 9 points from the second place. And the last 3, those 2 XYGY and GXY people in here thinks that Y is the worst choice, but there are no person who votes on those preference lists. So it is just 0. So if you add those 2 numbers, 6 and 9, then you got 15, right? Okay, then you can do the same thing for the G. So here, the last 2 preference lists shows that G is the first choice, first rank choice. So there are 4 persons who vote on last 2 preference lists. So G got 8 points from the first place. And in these green ones, G got the second places, and there are only 1 voters who thinks that G is in the second place. So G got 1 point in the second place. And the last, those blue circles, yeah, G got 7 people think that G is the worst cases, but still in this case, G only got 0 points. So what G will get from this vote accounting is 9 points, right? So here you can actually determine kind of social ranking, right? So here, y definitely greater than x, and x definitely greater than g, right? So from border counting, unlike the condition method, in the border counting, you can choose not only the best choice, but also you can find some ranking, right? Which one is better than, and which one is better, right? So here, y is better than x and x is better than g in the border counting, right? So if we choose only one person, then we can choose y, but if we need to choose two persons, then you can choose y and x, so on, right? So that's why border counting used when you need to choose some kind of, for example, senators or some congressmen in the state, right? Okay, do you have any question? Good. Okay, great. Okay, so then let's see some other example. So here, a sports award uses a rank method with 5 points for first place and 3 points for second place and 2 points for third place and 1 point for fourth place and 0 points for any place below fourth. Then we want to rank those candidates for using this. So for the first place, they have 5 points, second place, third place 2 points, and fourth place 1 point. I need to put those right in here. Okay. Then in the case, there are no, three preference lists. This first one, third one, and fifth one, who thinks that A is the first place, right? And there are 4 plus 2 plus 5, which is 11 voters thinks that A is in the first place. So this should be, A got 55 points on the first place. And this, the first preference list, they think that A is the second place, and there are only one voter who thinks that A is in the second place. So Eric got 3 points on the second place. And in the second preference list with this green one, A is in the first place, right? So I need to get 3 points. 3 times 1 is just 3 points in here. And there are no preference lists who thinks that A is in the third place. So A got 0 on the third place. So total, what A got on the list is, is 3 plus 3 plus 55, which is 61. Right? Okay, likewise, you can do the same thing for B. So here, for the first preference list, B is in the second place. And for the third one, the second one, B is in the sixth place, but so we don't need to care about this. And in the third one, B is in the fourth place. And in the first one, B is in the first place. And the last one, B is in the third place. So for the first place, there are only one voter thinks that B is in the first place. And for the second place, there are 4 voters thinks that B is in the second place. And for the third place, there are 5 voters thinks that B is in the third place. And for the first one, there are 2 voters thinks that B is in the first place. So if you add all those numbers, then it should be 14, 29. Okay. And you can do the same thing for C. So here, first one is in the third place, and second one is in the first place. Third one is in the third place. First one is in the third place, and is in the second place. So there are three voters who thinks that she is in the first rank. So she got 15 points from them. And there are 5% again who thinks that she is in the second place. So they got 15 points again from the second place. And there are 4 plus 2 plus 1, which is 7 persons think that she is in the third place. So she got 14 points from them and 0 for first place. So if you add all those numbers, then you got 44. And you can do the same thing for D, but there are not so much letters because you can see that actually only A, B, C, D, and F are in the first rank to fourth rank, right? So what we think that these D, E, no, not D. These E and G do not have any point, right? Because D and E and G are not in the first rank to the fourth rank. So we only care about A, B, C, D, and F. And in case of D, the first one first preference thinks that D is in the first rank, and second preference thinks that D is in the second rank. Okay, third preference thinks that D is in the second rank, and first one thinks that D is in the first rank, and last one thinks that D is in the first rank. So in case of D, only 5 people think that D is in the second place. So again, D got 15 points from them. And there are 4 plus 1 plus 5, which is 10 people think that D is in the first place. So D got 10 points from them. So it should be 25. And in case of F, F only happened in the second preference in third rank. So in case of F, it got 3 times 2, 6 points from third place. So that's the completion of the table, right? Then you can just compare those numbers so that the biggest number was on A, so A is the highest ranking, and second biggest number is C, and third one should be B, and D is the next, and F is the next, and now E and G has no preference, right? Using the rank method. Okay. Do you have any question on this example? Good. So in the rank method, what you need to do is just see which places the voting preference are and just count each point for each voting place, each rank, right? So that's what you need to do in rank method. And rank methods are often used for spiritual rankings. So yeah, in the United States, they are not popular on the soccer, but if you think about UEFA or some World Cup, like in soccer competition, then usually they give 3 points for teams who wins the uh, tournament or wins on the kind of the team matches, and 1 point for they draw, and 0 points for losers, right? So those rank methods are widely used on the sports tournament. And the next example, next method is run-up election. So from the majority winner, so we know that in the majority rule, maybe there are no winners, right? So in that case, uh, then we have another vote will be taken after eliminating one or more of the candidates. So for example, if we had election on ABC and A got 34%, B got 33%, C got 30%, then in the next round, we just drop C and then just take the election on A and B. So these are the system which will be used on the European ones. So if they got, especially France, if they got the has an election, then they just in the first round they just do the majority winners. But if there are no majority winner, then they only choose the last two person who got the most major, and they do the they vote against. So these are called runoff election. And if the top candidates could be in the runoff, the Harris system could be used. So in case of this runoff system, so if it starts with 3 candidates, then it goes to 2 candidates. But if it starts with the 4 candidates, then you can just go 3 candidates again, or you can go in next candidate again. So you can just drop out one in one for each election. But sometimes, doing election also has a lot of costs. So instead of doing this, we can use something called Hare system. So in the Hare system, if there is no measured winner, then the candidate with the purest number of first place votes is eliminated and results are calculated again. So instead of just doing the election again and again by dropping candidates, we just make all our peoples to give some preferential list, and using the preferential list without doing another election, we can just take the runoff election using this Hare system, right? So let's see some example. So in the Hare system, so the candidate with the purest number of first place will be eliminated, and just that preferential list is recalculated over the remaining ones. So for example, in the given preference list in example 3.9, first of all, if you just think about X, Y, Z in the majority winner system, then definitely X got 3 and 2, which is 5 points in the first round, because those two preference lists, X, Y, Z and X, Z, Y, thinks that, yeah, X is the best one. And from the YXG and YGX, we think that Y got 6 votes from them. And in the last two preference lists, G also will got 6 votes from them. And you can see that if you add all the numbers, then there are 17 voters in here. So majority winner should have 17 over 2, which is 8.5. But there are no one who got the 8.5 votes, right? So in that case, we need to just, instead of doing re-election, we need to just drop down the candidate with the fewest number of first place. So here, X has the fewest number of votes, right? So we need to just eliminate and recalculate those lists. And in this case, this X is just deleted in each preference list. Right? Then for first preference list, here definitely 3% thinks that Y is better than G, so 3% is counted as candidate Y, and 2% thinks that G is better than Y, so 2% is counted as a G, and the one voter thinks that Y is better than G, so this one voter will be counted as a voter Y, and this in the first preference list, definitely 5 people thinks that Y is better than G, so these 5 people also counted as vote for Y. And in the first or fifth one, 4 voters thinks that G is better than Y. And again, in the last 2, they also think that G is better than Y. Then you can recalculate the result. And here, Y gets 9 votes and G gets 8 votes. But definitely 9 votes is greater than 8.5, which is just the half of the voters. So here winner is Y. Does it make sense? Or do you have any question on hair system? Okay, so that is called hair system. So there are two kind of situation can happen. So for example, instead of 566, let's think about the example that 556 in the first round. Then what we need to eliminate is both X and Y, right? So in case is there are 2 or more candidates who got the purest but the lowest of both, then eliminate both. Right? Eliminate all, sorry, yeah, maybe there are more than 2, so eliminate all such candidate in the next round. That's one possible situation. Yes. Oh, so okay, so that's your. And okay, we have 5 minutes, so let's think about the sequential pairing. Then we will end the class. So here, sequential pairwise voting is very similar to the Condorcet method. It's a little bit different. So in sequential pairwise voting, candidates are compared 2 at a time in a predetermined order. Oh, sorry, predetermined. Yeah. Order known as an agenda. So we know the pairing is compared to the next candidate on the preferential list. Then this process continues until a winner is determined. So it means that if you have some preference list, and if there is some kind of list, then you can just pairwisely compare DNA, and the winner of this candidate is also pairwisely thought as B, and we can also think about C. So for example, if we just compare DNA without thinking all others, if D wins, then we can also compare D and B without thinking all other candidates. And if, for example, B wins, then you can just think about comparing B and C without thinking all other candidates. So that's the sequential pairwise voting. So, okay, so let's deal with some example here. So example 3.1.1. So assume that this following preferential list in here, then if you think about just Condorcet method, in here, definitely someone who thinks that A is greater than B or A is better than B is here and here, but not the third. So there are two voters thinks that A is better than B, but one voter thinks that B is better than A. So winner is A. And for A and C, first preference we thinks that A is better than C, and but the all other things that C is better than A. So in this case, C is the winner. And in case of A vs D, in the first preferential list, A is better than D, but second preferential list, D is better, A is better than D, but in the last, D is better than A. So here, there are two voters who thinks that A is better than D, but one voter thinks that D is better than A. So here, winner is A. And again, you can compare this like this. So here to compare B and C, first preferential list thinks that B is better than C, but second one and third one also thinks that B is better than C. So there are two persons who thinks that B is better than C, but one person who thinks that C is better than B. So here winner is B, and in the case of B and D, so yeah, if you calculate the Condorcet winner, you need to do such a tedious calculations. So in the first preference list, they think that B is better than D, so they're one person. And also in the second one and third one, all of the voters think that B is better than D, so there are three persons who thinks that B is better than D, and there are no person who thinks that D is better than B, so here winner is B. And in the last one, definitely only the second one, second preference, we thinks that C is better than D, but all other thinks that D is better than C. So only one person thinks that C is better than B at D, but there are two persons thinks that D is better than C. So here we know is D. So in this case, you can see that A wins B and A wins D, but C wins A, but B wins C, right? So definitely there is no Condorcet winner, right? Because in case of, there are no one who just wins every other candidate. So in case of A was beaten by C, and in case of C was beaten by D, but in case of D was beaten by A, so there are no Condorcet winners. No. But if you just think about the sequential pairwise winner, for example, if you think about the sequential pairwise winner with this sequence, then first of all, you need to compare A and B first. Then you know that in context of A and B, A is the winner because, here. And then you can compare A and C again. Then in case of A and C, C is the winner. And in the last, you can just compare C with D. And in here, D is winner. So in case of B, when we just make a sequential pairwise winner for sequence of A, B, C, D, then D is the winner. But if you just use the another one, B, C, D, A, then here B vs C in case B is the winner, and B vs D, again B is the winner, but B vs A, here A is the winner, so in the second case, A is the winner. So you can do the same thing for D and E, CABD and DBAC. And I repeat exercise because we already have the time. So, okay, so sorry for wait for the start of the each class, and thank you for listening. And now you can start the quiz in the website. The password is Congress, COGRESS. I think that's, yeah, correct. Okay, and if you have any question, please let me know. So I will just looking around here.
Professor Yu,
Yes.
I have a quick question.
Mhm.
Out of B and A, why is A the winner?
Oh, in case of A vs B, so here you can see that in the first preference list, thinks that A is better than B, right? And for the second preference list, A is better than B, but only
Okay.
third preference is, yeah, thinks that B is better than A. So that's why
Oh.
A is the winner.
Oh, okay. Thank you. It's just that I was looking at the winner column and I thought we were basing like who had more A's and who had more B's, but they both had 2 and 2.
Yes, because yeah, there are two persons thinks that A is better than B, but in case there are only one person who thinks that B is better than A, so that's why A is winner.
Okay.
Ranking is based on winner column. Ah. Yes, but yeah, so in the Condor's winner, ranking is actually not meaningful because in the Condor's winner, only the winner beats everybody, right? The candidate will beat everybody, but in the sequential pairwise winner, now ranking is, has meaningful because in that case, we can just compare pairwise, right? So doesn't your question? Okay. So doesn't you answer your question?
Yes, it answered mine. So then for D, the one that you just left for an exercise, would A be the winner if I did it correctly?
Yes, so in the exercise, if we think about the AC, okay, give me a second, CABD, then here you can just C and A first, compare C and A first. And since C is the winner, so that's why we have the winner on C first. And you can compare C and B again. Then in here, if you again compare C and B, then B is the winner. So that's why we got B as a winner. And if you compare B and D again, then, oh, sorry. B and in case of B and D, B is the winner. So the final winner should be B, right?
Oh, okay. This makes sense now.
Oh, great. Okay.
Yeah, I just had trouble picking which one was the winner. I thought we were doing it based off of the winner column, but it makes sense now.
Oh, great. Yeah. So this column is actually based column. Okay.
Okay, thank you.
Thank you. Is there any other question? And then I will just round down last one. In case of DMB, B is the winner. And in case of BNA, A is the winner. And in case of A and C is the winner. So in this case, He is the winner. Then stop here. Thank you for listening and see you in next week.